All right, guys, diving into the second page. So, I said this one was going to be a rate problem, right? So this one would be considered our rate problem. Notice as we read through this, it gives us a rate, right? 5 miles per hour, mph. That is considered a rate. So it says the speed of a current on the Scioto River is 5 miles per hour. A speedboat travels 13 miles with the current and another 13 miles against the current for a total trip of 16 over 3 hours. What is the speed of the boat in still water? So then we look at this hint. The hint says distance equals rate over time. So we need to go through this and see what we have. It looks like we have rates, 5 miles per hour. We have distance, right? 13 miles and 13 miles. The distance is the same. The current, and the total trip in hours. So we have some kind of t. The setup for these questions, guys, is we want to figure out what is the speed of the boat in still water, right? So we want to know x, the speed of the boat in still water. So these questions are a little bit tricky, but if you do a little manipulation of the distance equals rate times time formula, you can get this. Distance over rate equals time, right? That's just dividing the rate over to the other side, right? If we would divide by r on both sides, that would give us this equation. Then we can say distance that we traveled, 13 miles. What's our rate? Well, the rate is the speed of the boat, and then the current speed, which is 5 miles per hour. When we go with the current, we're adding to our speed those 5 miles per hour. Then if we add this, we're going 13 miles again. X is the speed of the boat, and then we're going against the current. So we would subtract 5 miles per hour off of our speed for a total trip time of 16 hours, 3 minutes, right? So distance over rate plus distance over rate equals time. That is how we build these formulas. So then we go least common denominator. We have x plus 5, we have x minus 5, and we have a 3. So then we multiply all of these things by that. Cancel out what cancels, so x plus, x minus, and then the 3. So then we multiply through. That's going to give us 3 times 13 is 39. X minus 5 plus 39 x plus 5 equals, let's multiply this out, x squared minus 25. So that's going to be 16x squared minus, anybody do 25 minus times 16 on their calculator for me? 400. Nice. So let's go through this now, right? That's 39x minus 39 times 5 gives us 195 plus 39x plus 195 equals 16x squared minus 400, right? Negative positive, so that gives us 78x equals 16x squared minus 400. Quadratic, x squared, so we subtract the 78x to the other side. And you get 0 is equal to 16x squared minus 78x minus 400. Now, hopefully this factors and we don't have to use quadratic formula with those big numbers, right? So we go here, we say, what is the biggest number that we can pull out of all of those? 2 comes out of that for sure. Let's see if 16 comes out of it. It's nice to us. It does not. 78 divided by 8. Nope. 78 divided by 4? No, only 2? Are you kidding me? So only 2. I guess that makes sense. 39. Okay, So we divide by 2, divide by 2, divide by 2, divide by 2. 0 is equal to 8x squared minus 39x minus 200. This has got a factor, but I don't know. Let's just throw it into a calculator, right? Now we say 8x squared minus 39x. Whoops, didn't do the squared. 8x squared minus 39x minus 200. Boom, we get zeros. Oh, look at that. Factors into x plus 8, and then 8x minus something. So our answers for this question are x is equal to, whoop, they went away, negative 3.125, and x is equal to 8. Dang, okay. So if we look at this, we go back to what was x. X was the speed of the boat in still water, right? So then we have these two different numbers. Negative, I'm going to get that calculator out of the way. We have negative 3.125 and positive 8. Well, which one of those things can be speed? Speed is always positive. So then our final answer is going to be x is equal to 8 miles per hour. Okay, so slow boat, right? Not going very fast. But that's exactly how you do these questions, guys. Let's do one more. All right. So this one says Mrs. Horn runs a 200-meter dash in 25 seconds. The wind was at her back for the first 150 meters, moving at a speed of 3 meters per second. So let's kind of take all that in, what we just had. Mrs. Horn runs 200-meter dash in 25 seconds. So that's telling us she went 200, distance equals rate times time. So if we solve this, right, divide by that, with d over r equals t. So the distance she went was 200 meters. It says the wind was at her back for the first 150 meters. Oh, so the distance that we're talking about, 150, okay, moving at a speed of 3 meters per second. So my guess is, what speed can Mrs. Horn consistently run for 200 meters? Why did I put an X there? 150. Okay. The wind was blowing in her face the last 50 meters at a speed of 1 meter per second. What speed can Mrs. Horn consistently run for 200 meters? So then we want to know x in this case is her constant speed. So when she runs the first 150, we say it's x, and then the wind's pushing her, right? It's aiding her speed, so it's adding on to the speed. It's adding 3 meters per second to the speed. That last 50 meters, though, there's a big gust of wind. So for the last 50, it's pushing against her, so it'd be x minus 1. How long does it take her to do it? 25 seconds. So then our total time would be 25. Now we have our LCD, x plus 3, x minus 1. And then we multiply all of these things. X plus 3, x minus 1, times x plus 3, x minus 1, times x plus 3, x minus 1. Cancel what cancels, so that's going to be 150x minus 150. This is going to be 50x plus 150 equals x squared plus 2x minus 3. So that's going to be 25x squared plus 50x minus 75. 150 and 150 cancel, so that's 200x. All right, so 200x is equal to 25x squared plus 50x minus 75. So minus 200x minus 200x. 0 is equal to 25x squared minus 150x minus 75. So that's the setup for that problem. Well, setup and then setting it equal to 0, sorry. If I went a little fast, please let me know what questions you have, guys. And then at the end of this, as you can see, I said, do you remember the quadratic formula? So I'm guessing I didn't let this one factor nicely. So let's do a little quadratic formula business to this. One nice thing we can do before quadratic formula, though, guys, is we can get 25 to come out of all of these things, right? So we divide everything by 25. That would give us 0 is equal to x squared minus, what's 150 divided by 25? I'm slow at math. 6x minus 3, okay? So because we can pull out 25 out of all of those things, now we can do the quadratic formula. So quadratic formula, x is equal to the opposite of b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Solve this out, we get 6 plus or minus, whoa, that was a weird 6. 6 plus or minus the square root of 36 plus 12 over 2, which is equal to 6 plus or minus the square root of 48 over 2. Okay. I guess we could keep going, but honestly, we just need to know what number this is because it's a word problem. So if I type in my calculator 6 plus the square root of 48, and then divide that number by 2, you would get 6.46, or if you would do 6 minus the square root of 48, divide that by 2, you would get negative 0.46. So it looks like our positive 6.46 is going to be the one that we want. So 6.46, what's our units? Units are meters per second, so we got meters per second here. So it looks like Mrs. Horn runs 6.46 meters per second. Okay, and then you could always check with your calculator, right? Checking with our calculator, we just plug in our original equation. So 150 divided by x plus 3. Whoa. X plus 3, and then, oh my gosh, plus 50 divided by x minus 1, and then it's equal to 25. So we scroll out here. Oops, we'll say y equals 25. Negative 0.464, 6.46. There it is, booyah, 6.46 meters per second. All right, guys, that is all of the rest of the notes for this unit, okay? If you have any questions, please post them in the discussion. Check out the key, okay? And yeah,